Happy Monday. I hope you guys, second period, you are doing well. We are beginning week 2 of digital virtual learning. I kind of started off kind of a lot last week, and then I don't know if you noticed, but I tried to slow it down a little bit as the week went on. I do not want you to feel overwhelmed, but I do want us to continue to learn. So if at any point you feel like it's too much, just let me know. I'm going to try to, excuse me, still continue to teach, and hopefully you guys are kind of gaining some information while we're not actually physically together. I'm not really trying to do any chats so that you guys can kind of do it on your own, but if you feel like at some point we need to do like a face-to-face tutorial session, or like where we use Google Hangout or Zoom or something like that, we certainly can. You just need to let me know. Okay? So, our goal for the next couple of days is to kind of wrap up parallelograms. Okay? We kind of did our practice on Thursday and Friday, and you didn't really have to send me anything. So I haven't really seen your work since Wednesday, and so I really want you to send in some stuff today. I'm trying to get Google Classroom figured out. That is new to me, I'll be honest. And so if I can get that figured out, I think it'd be easier for me to have all of your responses right there, because going through Remind is kind of a lot. But anyways, I'll let you know through Remind if I get it all figured out. But regardless, I think the video will be helpful. So we're going to have a quote-unquote quiz. I say that because obviously it's not like a real quiz tomorrow, because it's not really going in the grade book or anything. However, it is for me to give you feedback to tell you if you're on the right track or not. I really hope and pray that we'll be back in school, but I don't know if that's actually going to legitimately happen. We'll see. But my hope is that we can kind of get back together, with a few weeks left of school and review this stuff that we've already done instead of having me to teach it all again. Okay? So with that being said, today we're going to practice one more time with parallelograms, and then tomorrow we're going to have a little graded assignment. All right, so if you want to, I'm going to work through 1 through 10, and then if you notice there's some blue dots beside some problems, I'm going to work the ones with the blue dots, and then you're going to work the other ones. Okay, so there's going to be about, I would say, like 10 problems that you're going to do, and that's it. All right, I'm going to have a sip of water really quickly. Okay, so number 1, or let's read the directions. Justify each statement using a postulate, theorem, or property for parallelogram ABCD. So basically it's asking, how do you know that you are allowed to say that AD is, and what does this symbol stand for? That symbol stands for parallel. So how do we know that AD is parallel to BC? Well, that's because it says the word parallelogram, right? And we know that in a parallelogram, opposite sides are parallel. That's our postulate or theorem. Okay, so it's basically just understanding those characteristics. All right, well, how do I know that DE is congruent to EB? So what postulate or theorem allows us to make those marks? Now, I hope if you are noticing D to B and A to C, these are called what when they cut through the figure? Those are called diagonals, okay? So it needs to be something about the diagonals. Well, what do the diagonals do in a parallelogram? Well, the diagonals, it starts with a B, bisect each other. Okay? So we know that DE would be congruent to EB, and then we would know AE is congruent to EC, excuse me. Now, they're not all 4 going to be congruent, but just those sets. Okay? Well, I guess I can leave that up there. That's no big deal. All right, now it says, let's get a different color here. It says ADC. So A to D to C. That's this whole angle right here. And then DCB. D to C to B. That's this whole angle right here. What do we know about those? Oh, well, it says they equal 180. So they're not congruent to each other, and that's because they're not opposite each other. So what is that when they're right beside each other? I think the word that we used, or the woman used when you first learned it, was consecutive. So consecutive, is that spelled right? It doesn't look right, does it? Consecutive angles are, and then 180 means supplementary. All right, so we know those are some very important properties about parallelograms, okay? All right, so now let's go through and mark something about the characteristics of each of these, okay? I'm going to zoom in a little bit. All right, so which figures have diagonals that are congruent? So not a parallelogram, a rectangle is a yes, and then the square is a yes, okay? All right, opposite angles are congruent. So is a parallelogram, are opposite angles congruent? Yes. And so what did we say in the video on Friday? If it works for a parallelogram, it works for all of them. And that's because all of these are parallelograms. Okay, they're just called special parallelograms. All right, diagonals are perpendicular. So that's like where you had, oh goodness, that's so bad. And you could go like this, you could put the right angles in there. And so that is the rhombus and that is the square. Okay? And so then, let me erase this horrific picture. All right, and so then all angles are right. Well, that's not a parallelogram. That does work for a rectangle and it does work for a square. Diagonals bisect each other. So that's the one that we just set up here on number 2. Excuse me. So it does work for parallelogram, and if it works for parallelogram, it works for all of them. And then all sides are congruent. That does not work for parallelogram, that does not work for rectangle, but it does work for these two. Okay, so you think you could do something like that on your own? Hopefully, if you have these kind of written down, if you get to use your notes and stuff on a graded assignment, quote unquote graded assignment, then hopefully that won't be too bad. Sorry, having another sip of water in my throat. The pollen, is anybody else having trouble with the pollen? I sure am. Okay, so I'm going to do 2 in this section about parallelograms. So note the very first thing I'm going to do is say, all right, what is the shape? So this is a parallelogram, okay? And it says the measure of angle 6 is 68 degrees. And then it says the measure of angle 7 is 45 degrees. And it asks us for 10. Okay? So this one actually is pretty easy if you remember our rule about... Okay, so is it going to go like that? Alternate interior angles? Well, that would put 7 equal to 11, and that's not what we want. Okay, so let's use a different color and see if we can do it with a different set. So let's see if we can go like this and make our N as opposed to the Z. Yeah, that should work. Okay, so if 68 is here, then it's the same here. Okay, so it should be 68 degrees, and the reason is because of alternate interior angles. And you guys, oh, I guess I should have said this. If you think you already know this and you don't really need to watch me, work through some of the problems, you just pause, go right ahead, okay? And you can work all of them if you would like, and then you can check your answers, fast forward and see it. When I erase that, I erase my marking. Okay, number 13 is the one I said I would do next. Okay, so number 13 says, if the measure of angle SPQ, S to P to Q, so this whole angle is 5x plus 17, and then PSR is this whole angle, which is 3x plus 11, then find x. Okay, so here's what we need to do. We need to ask ourselves, what is the relationship of these two angles? Are they congruent or are they supplementary? And the answer is, because they are consecutive, they are supplementary. Okay, so on number 13, I'm going to come down here and I'm going to do 5x plus 17 plus 3x plus 11 equals 180. Because now if I had said this angle, then yeah, we could say that 3x plus 11 is equal to this angle. But we didn't say that. We don't know opposite angles. We know consecutive angles, okay? So let's go through. Get your calculator if you don't have it handy, and let's add these up. So we're going to do 8x, because they're on the same side of the equation, plus 28 equals 180. And then I'm going to subtract the two. So 180 minus 28 will give me 8x equals 152. And then divide by 8. So x will equal 19. Now, I've told y'all that good students can be excellent students if we check ourselves. So I'm going to do that really quickly. So I'm going to plug in 19 and see what happens. Brian sent me this question. I don't think he minds me calling him out. That was awesome. He sent me a question from before. It was earlier in the week, last week, and said, I get the math, but it doesn't look right. Like the angle was obtuse, but we got 25 degrees or something like that. And it was an excellent question. So A, that means it was a poor question on my part, but B, we also have to remember that sometimes questions are just, or pictures, are there to help us. They're just like an aid. So it doesn't always mean that it'll be drawn to scale. All right, so just FYI on that. All right, so let's multiply these. 5 times 19 and add 17, and we get 112. And then 3 times 19 plus 11 gives us 68 degrees. All right, wait, so were we supposed to get them equal to each other? The answer is no. We should get that these two equal how much? They should equal 180. And if we do 112 plus 68, I'm literally holding my calculator and typing that in. Do I get 180? And the answer is yes. So that probably means we are on the right track. Okay? All right, so I'd like for y'all to pause the video and try 11, 12, and 14. Okay? All right, with the rectangle, I'm going to remind you of probably the most important rule, which is the isosceles. So, isosceles triangle, So I'm going to go like this. That always helps me with the rectangle, okay? And I'm going to put 35 degrees in here. Do y'all remember that warm-up question we did where I said if you have one angle, you can find all of the rest of them? Okay, so we should be able to find everything else based on just this simple 35. All right, it's asking us for angle 9. Alrighty, so the first thing is, you remember our isosceles triangle rule? So if this is 35, then so is this. And so then we can find this triangle sum is 180, and so we're going to do 35 plus 35, which gives me 70, and then I'm going to subtract that from 180, which should give me 110 degrees. Now, why did I find angle 10? Well, I found angle 10 because angle 9 is right beside it. Okay, so what do we know about these two angles right here? Angle 10 and angle 9. Well, if they are right beside each other, then they make a linear pair, right? So if this is 110 and at angle 10, then this one has to be 70. And that's because they are a linear pair. Okay? Now, there's other ways to do this. You could have also done, I'm just going to show you another way. Let's go back. All right, y'all know how I did the isosceles triangle thing here? Well, you could have run with the fact that this is a right angle in the corner. And so if this is 35, then this would have to be 55. Because 55 plus 35 gives me 90. And so then I could do this whole thing here, 55, and then add up 55 plus 55 to give me 110. And then do 180 minus 110, which still gives me 70. Okay, so I've shown you two different ways to come up with the 70. And that's completely up to you. Whatever you see best. All right, I'm going to put 110 in here to kind of remind you. All right, I'd like for you to try 15, 17, and 18. Okay. All right, we're going to do the rhombus. So I think I remember telling y'all that really like the first thing that I do is I go like this all the time and like this. Okay. All right, so number 19 says if the measure of angle 1 is 24 degrees, then the measure of M N O. So let me outline it. M to N to O. The reason this is a trick question is because do y'all see it's not just angle 5 or not just angle 6, it's both of them put together. Okay, so we learned a rule that said the diagonals bisect these angles, so these are both 24. And then we can kind of pair it back with the parallelogram rules, which says alternate interior angles. So then this one's 24 and this one's 24. And so now, how do I find that whole big MNO angle? I'm just going to add them or times them by 2. So we're going to do 24 plus 24, which gives me 48 degrees. Oh, the degree is already there. Okay? All right, and now for the challenge question. The challenge question is wonderful. Okay, so it says if MO is 10, so this whole thing is 10. And then PN, this whole, I'm saying thing, I should not say thing. This whole diagonal, excuse me, is 24. Now, that's really hard to tell because they're like overlapping each other. So you know what I might do? I might break it up by the diagonals. So if MO is 10, do y'all agree this would be 5 and this would be 5? Because they bisect each other. The diagonals bisect each other. And so then if PN is 24, then half of 24 is 12 and 12. Okay? And now it's asking us for MN, which is this side length. Now that is very tricky because there are no other side lengths given. So we're going to have to use this 5 and this 12. So I'm going to redraw this picture over here to the side. And I'm going to kind of turn the triangle on its side. Okay? So just think about turning your computer screen or your phone screen to the left a little bit. Okay? Like twisting it to the right, but putting the bottom side towards the left. Okay? So M to X is here. It is 5. X to N is here, and it is 12. I got that because I divided both of these by 2. Okay? Now, there is this thing that you learned in middle school. We have talked about it maybe a couple of times. Not much, but a couple of times. And it's called Pythagorean theorem. We're going to talk about it a lot more in the next couple of weeks. Okay? Pythagorean theorem is a squared plus b squared equals c squared, and it only works with right triangles. Okay? Only. But this is a right triangle. So it could be used in a rhombus. It could also be used in a square, because a square, do y'all agree, we also do that thing, okay, where the diagonals are perpendicular. I get really excited about this because a lot of times students, it's kind of hard to see, but once you know it's Pythagorean theorem, y'all are pretty good at the Pythagorean theorem, okay? So we're going to plug in 5 squared plus 12 squared. Do you remember that C always has to be the hypotenuse? Okay? And the way you locate the hypotenuse is it's always across from the right angle. Okay, so that's our unknown. You can put it as C, you can put it as X, whatever you want. All right, so we're going to work this. 5 times 5 is 25. 12 squared is 12 times 12, which is 144. And then we're going to add those together to get 169. And then how do we get rid of the squared? We're going to square root both sides. So now these cancel each other out. And is 169 a perfect square? And the answer is yes, it is. Yay. So If you type it in the calculator, you're going to hit like second and then the x squared button and then 169, and it should give you 13. So there's a little fun tip about rhombi, that you do not have to know the side lengths at all to find them. If you know the diagonals, that is enough information to find the side lengths. So this would be 13, and then all of them would be 13. Okay? That would be like a bonus question. I don't want you to get to fret and think like, oh my goodness, that did not make a whole lot of sense. That was just a little bit of a challenge question, which is why I picked it. All right, I would like for you to now do 21 and 22. And then I debated you guys about the square, whether I thought you needed me to do it or not. I honestly don't think you really need me to, but I will just to be sure. Okay? So remember that you know all of the angles. You know they're all 90 in the corners, and they're 90 here in the middle. And then you know that all these are 45. Okay? Like all the way around. That'll help you answer 23 and 24. All right. Now 25... There's a similar question above. I think it's in the parallelogram section. So you may already feel confident with this, but I just wanted to explain it. So it says, if RA, which is this whole diagonal, is 3x minus 11, and then EY is this little portion right here, is 20, then find x. So, are they equal to each other? I hope you can see the blue is much longer than the green. And how much longer than the green is it? It's 2 times as long. So, if we want to put it equal to the green, we're either going to have to divide it by 2, or we're going to have to take this little 20 and times it by 2, or double it. Okay, so what would this whole length be then? It would be 40. So for number 25, I'm going to come down here and I'm going to say 3x minus 11 does not equal 20, it equals 40, because we have to double it, okay? So we're going to add 11, and we're going to get 3x equals 51, all right? And then we're going to divide by 3. And so then x equals 17. And now I'm going to ask myself, is that all that they wanted in this question? And the answer is yes, that's all that they wanted. Okay? All right, so now you just need to respond to me the how many questions. Let's go back and review. So it was 1, 2, 3 from the beginning. So 11, 12, 14. And then 3 more. So that's 6, 15, 17, and 18. 2 in the rhombus, so that's 8, and 9, 10. Okay, I was right. So only 10 questions that you need to answer. It would be easier for me if you number them, like 21 is this, 22 is this, 23 and 24, etc. Or you can take a picture of your work, whatever you would like for me to do. Whatever you would like to do for me. So it doesn't make a difference. Anywho, hope y'all have a good rest of the day. Try to get those done, and we will move on and have a little quote-unquote assessment tomorrow. Y'all are doing great. See you later.